Let's start with the structure of ether. So ether, alcohol, water, they have very similar structure. They are bent, right? The geometry are bent. The only slightly different is the bond angle. And the only reason that if you go from water, hydrogen, methanol, carbon, hydrogen, and dimethyl ether, carbon, carbon, the only reason that the bond angle is larger because of repulsion between the big group right here. Right, small groups like two hydrogen, they don't have much repulsion, 105 degrees. Larger group, 112 degrees. That's how it works. Okay. The boiling point of ether is somewhere between ethanol and propane, so it's an alcohol. And you guys know this guy came from hydrogen bond. Propane has nothing except London forces, right? Dimethyl ether got somewhere in between because it got dipole, right, and the London forces. So look at that. The polarity or dipole moment point up to oxygen right there. The larger ether have higher boiling point because the higher degree of London forces. It's just more carbon, more carbon, more carbon, even more carbon there. All right. And what's it? Ether by itself cannot be cannot form hydrogen bonding. But if you mix with water, right? This is an alcohol or alcohol. This is alcohol. Ether can act as a hydrogen bond acceptor because they got an oxygen. But by itself, like just either they cannot form hydrogen bond. They need an OH bond right here. Okay. All right. Ether is usually used as a solvent, and the only reason is they got low boiling point. It's easy to remove. So think about it. When you set up the reaction, you add reactant, catalyst, solvent, right? And at the end, let's say you have product. You want to remove everything that's not a product. You want to get the pure product. The solvent that have low boiling point that has a big advantage compared to water. Water is really, really difficult to remove. They got hydrogen bonding with pretty much everything. Okay, and the ether is super easy to remove, and we have seen some ether that we use in the reaction before. We have a diethyl ether, we have tetrahydrofuran, so you have seen it before. Haven't seen 1,4-dioxane yet, but yeah, not that common for this class. Okay, inert to most compound. One of the biggest property of a solvent that any solvent need to have is does not react with any reactant of the product. Otherwise, you just destroy the reaction, right? So it's going to be inert, and usually ether is inert, doesn't have acidic proton or the hydrogen right here, pH 50. Nothing can deprotonate it. All right, and fairly polar. So unlike hexane also inert is all carbon chain. But the big disadvantage of using hexane is cannot dissolve anything that a little bit more polar than hexane, and it not dissolve. So, but ether add a little bit polarity because of oxygen here. Add a little bit of polarity into the solvent, and can dissolve a lot of compounds, even like Grignard reagent. Totally Grignard. This ionic bond right here. You cannot use hexane with it, right? So that's the reason we use quite a lot of ether in the organic synthesis. Okay. All right. Let's take a look at the application of ether.